Hi guys, so here's a circuit about had a viewer want the schematic for being able to run that Hall effect circuit or any of that circuit with 120 volts input. And I told him I would show a really easy circuit to use just to subtract. Like, say you have 120 volt DC input that you want to run the motor with, right? So, but you need 12 volts to run the pulse circuit, which will fire the PNP transistor and the NPN MOSFET that's actually going to be running the coil, right? Turning the coil on and off. Well, here in this case, the load is going to be that 555 circuit. So this part of the circuit right here is going to be, let me see here. You're going to add it right here. You'll have your VCC in. And there's your negative going in, right? For the voltage regulator. But you want that before the voltage regulator. It doesn't matter which leg you put. Okay, this is the second circuit I'm going to show you guys. This is the one I just drew up. Right here. So this is the one I'm showing. This is for DC input. So it doesn't matter which one you have going through this bridge like this. Goes in series on the EC legs of the bridge onto your load. You can do either leg, doesn't matter. Positive or negative. That's all there is to it. What happens here is you have a battery equal voltage to what you want to subtract in voltage. So if you want 20 volts here, let's say, you have 120 volts in, you'd have a 100 volt battery bank. Doesn't have to be perfect because you're going to be feeding a voltage regulator over here, which is, anywhere from 12 to 14 volts. That's going to be fine, even up to 16 volts. Closer you can get to what you need is better though, but it gives you leeway in what your battery's doing up here. Because what's going to happen is you're putting DC in here, you're getting DC out here, and this battery is going to charge at the same amount of current as what you're using here. So whatever is going in through here for current is the same amount you're going to be getting right here. So I have this set up right here actually. So what I have here, I don't have a DC input. Well, I do now because I'm using a bridge rectifier right here, right? So it's going to be DC in. The negative from this bridge rectifier, like this is going to be 120 volts-ish. Because that's a light dimmer switch I have it hooked to, and it's going to be plugged into the wall, 125 volts AC. So you can see the negative comes right here, goes to the sender of that bridge rectifier, first leg in it for the AC, and in series comes out, and that acts as your negative. And I just have a 120 volt microwave oven light bulb right there, up to it right there, and the positive is there, and it just goes straight to the positive leg of the bridge rectifier directly in. And then this bridge rectifier has its negative leg comes here to the negative of the battery, These are all in series. These are about 24 volt. These are each 16 volts. So you're getting 85 volts for that battery bank. Just what I had laying around. So, and then here's the positive hook to it right here. So, okay, I'm going to plug this in now. I think I have it set so that it's getting roughly around 13, 14 volts to the light bulb. Just plug this in now. Couldn't get it to. Okay, and what you're going to see is the battery bank is going to start to charge. There, it's plugged in. The light is on. Getting roughly 13 volts to the light bulb. Because we're subtracting 85 volts from this circuit. Because it's charging the batteries. So I'll just short this one out. And it should give like, well, let me turn this up first. I'll turn it up all the way. So it's roughly around 30 volts or so when it's on full blast. Because you only get maybe 105 volts out of these when they're full on all the way. So now I'm going to short this out as if there's no bridge rectifier right here. It'll be just like taking the DC from here and putting it directly to the light bulb. Try to do this without shorting anything else out though. It's not exactly the safest thing to do here. Especially with one hand. There. Okay, let me try to film all this. Okay, there. Trying to do this. See the when I short it out, the battery stops charging, and all the power goes to the light bulb. I'm trying to just hold it on there without shorting anything else out. But you get the idea. It just eliminates that bridge rectifier. But with that in circuit, it subtracts that voltage, the same amount of power. And it, let me see here, let me turn on one of these meters. So I've turned that on now and you can see there's 66 milliamps of power going through the circuit. So it's charging that battery up at 66 milliamps. So, 85 times 0.66 milliamps. .066 milliamps, sorry about that. Got like 1.6 watts per that in that battery. It'll be roughly the same in this one, and it'll be less for those two because this is a 16 volt battery. So you're burning up probably about 5 watts of power here to resist all that voltage, which would be going into here. If that makes sense. Which, if you were trying to do that with a resistor, you'd be burning that power up anyways. Like this circuit doesn't resist amperage. All it does is reduce the voltage, and in turn your circuit, your load sees less volts, so in turn it's going to use less amps. That's how it works. But I'll also be posting another video after this one of this circuit. Got too many papers here. See if I can find it here now. So this is the circuit here. If you were using an AC input, this is what you'd need to do. This will also work with a DC. It's just a little more complicated, but if you want a DC input here with an AC load, you put it like this with two bridge rectifiers in series like this, and you run this one to your load and this one to your battery, and that'll give you DC here with AC going in.